Hi guys, good afternoon. So in the last session, we went with the GRE, right? Route-based VPN we have started. Now, yesterday we saw that when we were transmitting the traffic to our GRE tunnel, was it secure? No, it was not secure. So today what we'll do is we will secure that traffic, okay? And before that, I gave you some tasks, right? GRE over IPSec, IPSec over GRE. So what's the difference?
IPSec provides secure and flexible channel solution, providing the benefit of IPSec encryption and GRE calculation. It may introduce additional overhead and complexity.
Okay. And what about IPSec over GRE?
Secure and flexible channel solution, providing the benefit of IPSec encryption and GRE connection.
Same
It may introduce additional overhead and complexity.
Same thing.
Basically, IPSec is integrated to GRE. Basically, IPSec is integrated to GRE tunnel. And instead of GRE over IPSec, GRE is encapsulated to IPSec.
Again, you said the same thing.
But in the IPSec over GRE, that is more secure.
Is it? How?
IPSec over GRE tunnel and GRE over IPSec GRE platform.
Online people?
IPSec over GRE is more secure.
See, actually, in the real scenarios, what you will see is GRE over IPSec only. Why? Because with the help of GRE over IPSec, you are able to transmit a broader range of traffic. But in case of IPSec over GRE, you need specific traffic only. Okay, and your IPSec over GRE is not really being used at also. Very rarely you will see. Okay, almost everywhere you will see what GRE over IPSec. So in GRE over IPSec, what do you have? You have first of all your GRE in which GRE tunnel in which your traffic will be passing, and then that traffic, that GRE tunnel will be encapsulated with the IPSec security. Okay. And even if you will search in Google also, see here. Technology is same only, right? Okay. So mostly we will go with what? See here, according this is. Sorry.
Means GRE transfers the Unifax and Boardfax. Then this IPSec transfer to the Unifax only.
Is it? See here, okay, this is community only. And this image you can see. That in GRE over IPSec, additional overhead is added to the packet by encrypting the GRE header also. Okay. So here what will happen? Even your GRE header will be encapsulated. And here it says like IP multicast and non-IP protocols are not supported in case of GRE over IPSec. Okay. Then it supports dynamic IGP routing protocols. Your IPSec over GRE does not support. Like if you are using dynamic routing protocols, so you cannot use IPSec over GRE, right? So yesterday itself for site-to-site communication, we used DIGRP because every time you're not going to go and provide what? A static route. Because how many static routes you'll provide? So what do we use? We use the GRE over IPSec where we can use the dynamic routing protocols also. Okay. And here it says like additional overhead is added to the packets by encrypting the GRE header. So that means it is saying that there will be extra header will be attached, but that we can reduce. we have features like SVTI. Okay, we have features like SVTI, with the help of which we can reduce the GRE header also. Static virtual tunnel interface. Okay, that is the SVTI. Okay, like VTI is what? Virtual tunnel interface. So that is SVTI, static. Okay, so with the help of that, what we can do is we can go and remove the GRE header from inside. So that means this extra overhead, we can remove it. So that's why always and always what you will see in the implementation, GRE over IPSec. This is very less commonly used. Okay. All right. So what we are going to see is about GRE over IPSec only. Okay. This is configuring IPSec over GRE. Here you can see. This is entire book from Cisco. Okay. And this is using here IPE version 2. Okay. Right now we'll go with IPE version 1, what we have already seen. So this also, let me download it and I'll share it with you guys. Okay, I'll share it in the drive. Now, playing music. Okay. I have to power off by FTD. Entire FTD. Shut down. Okay, unfortunately, we had another. Now let's start. This process will remain exactly similar only. Okay. Just here, we don't require the crypto map. One step will change. Instead of crypto map, we will use IPSec profile. And that IPSec profile we will apply on the tunnel interface. Very small change. Okay. Now onwards, whatever you will see, right? So everywhere you are just going to see small changes on. Okay. For this, we have next concept, MGRE and DMV. MGRE. Right now we are studying GRE, right? So from one side to another side. But what if you have multiple sites? In that case, we have two options, either MGRE or DMV. So MGRE is static. That means we have to statically map each and every site. Okay, that means individual tunnel will be there and we have to statically map every single site. In DMVPN, this will be automatic, dynamic. Okay. So we are done with the GRE. Now let me clone this lab. Rename it. Over IPSec. Okay. Wipe all the notes. We'll do the basic configuration. Ready? Just one more. Let me open the notepad. See, you cannot say this thing over in Python. Hmm. In CCNP advanced? Or which advanced? What are you talking? Yeah, DMVPN is there. I think MGR is also there. Not there? Maybe not mentioned, but yeah. Mhm. If DMVPN is there, so before understanding DMVPN, MGRE should be there. If you understand MGRE, your DMVPN becomes very easy. And that's why we say advanced routing is required. Yeah, 2 days you have. Just 1 minute. Okay. So you guys can go through the MGRE and DMVPN concept in the weekend, and you have to search for one is NHRP, second one is NHS. Okay. NHRP, NHS. NHRP, NHRP, NHS. Redundancy. One day, one weekend practical. Why not? Think about it. Hmm. But what if I have more? Hmm. And this thing you'll come to know when we go with the multi-site in the MGRE and 10.2.2.2. So since this is route-based VPN, we will not require ACL. Okay, so ACL will not be required, and cryptomap we will not use. Instead of cryptomap, we will use IPSec profile. You said you're not good, you're doing very well. Have some confidence.
Can I do this GRE?
Sure. Just mention. No problem. Just mention here. Configure tunnel interfaces. Start for site 1 and site 2 tunnel interfaces. It's okay, just keep it site 1 only. Fine. I have already mentioned, right? Configure tunnel interface. Tunnel source, correct. So here we can mention the IP address as well as the interface name also. Both are fine. Destination 112. So right now what we are creating is VTI, virtual tunnel interface.
You have to be submitted.
In the IP address, always subnet mask will come. For site 2. Exactly. Let's copy paste, power up all the notes. So once we configure the tunnel interface, we have given the source as well as the destination. Okay, so first of all, the first thing we will test is we are going to test the communication from public to public. Then second testing we will do is tunnel to tunnel. Okay, and since you have mentioned the tunnel source as well as the tunnel destination, you should be able to ping from 192.168.1.1 to 192.168.1.2. Okay, and for loopback communication, what we can use? AGRP we can use. Okay. Site one. Site two. And ISP. So let's configure site eight. Site two. And then we have ISP. Now we should be able to ping from public to public. So do ping 12.1.1.2. I'm able to ping. Now what? We will configure the virtual tunnel interface. Okay, so on site one, we are saying interface tunnel one, source is 11.1.1.1, destination is 12.1.1.2, and this is the IP address we are assigning to the tunnel interface. Okay, so copy, paste here. Same thing. According to site 2, the tunnel source will be 12.1.1.2 and destination will be 11.1.1.1. Okay, so source is 12.1.1.2, destination 11.1.1.1, IP address 1.2. Done. Now what? We should be able to ping the tunnel interface also. You pin 192.168.1.2. We are able to pin, and also we can verify that our tunnel interface here is, the protocol is also up. So in which case your status will be up, but protocol will not be up? No. When you have not given tunnel source and destination. Tunnel source and destination will be required for the tunnel interface to come up with the line protocol. Okay. All right. But right now, if I check here, if I go and capture the packets, if I try to pin, first of all, from pin 192.168.1.2, so I can see some traffic is going on using what? GRE. GRE header it is using, it is getting encapsulated. Okay. And if I check whether my loopback to loopback communication is there or not, do ping 10.2.2.2 with the source as 10.1.1.1. So I will not have the communication. Why? Because first of all, no route. I don't have a route to reach 10.2.2.2. So for loopback communication, either we can go and create a static route, or else we can use dynamic routing. So right now, what we're going to use? Dynamic routing. Okay. So if we will configure what? EIGRP. Configure EIGRP for loopback communication. Okay. So on the site one, you will see a router EIGRP 100, no auto summary. Then we will do the network 10.1.1.0, and then network 192.168.1.0. And this is done. For site 2, router EIGRP 100, no auto summary. Network will be 10.2.2.0, and another network will be 192.168.1.3. This is clear. Let's go and copy paste. Copy, paste here. Copy, paste here. EIGRP neighbor, first of all, neighborship came up. And if neighborship came up, we should have a route also now. Do show IP route. So if I check, I have a route for 10.2.2.0 via the tunnel interface, and this side will show IP route. So I have a route here for 10.1.1 via the tunnel interface. So that means now I should have loopback to loopback communication. Do ping 10.2.2.2 with the source 10.1.1.1. So actual source is 10.2.2.2 and actual destination is zip. Okay. So source will be 10.1.1.1 and destination will be 10.2.2.2. Okay. Don't blindly say yes. Okay. So if you see in the Wireshark, it will show you the real IPs only. But in actual, if you will really see the packet, actual communication will happen between, because this your ICMP is encapsulated with the GRE. So when your traffic is passing through the ISP, right? ISP is able to see that communication is happening from here to here, not from 10.1.1 to 10 to 2. This is clear. But right now, this tunnel is not secure. We can clearly see all the traffic inside. I have captured the packet. Inside the packet, I can see that, okay, it is what? IPv4 packet. Okay, and what is the protocol here? ICMP. Correct. So now what? We will apply here IPSec security. Clear? So let's go and apply the IPSec security here. Now, so far, configure IPSec to secure the on the site one. First of all, what do? We create what? ISACAM policy. So we say crypto ISACAM policy. That's it. And then Haggle. So hashing. Let's go with SHA-256. Authentication is free share. Group is 14. Encryption is AES. Lifetime, if you don't configure also, no problem. 86,400. This is done. Then we configure the key. So we say crypto ISACAM key Cisco and peer address. Now what is my peer? 12.1.1.2. Up till now everything is same. Okay. Then after the key, what we are doing? Phase 2 transform set. So we'll say crypto transform set. Name is tset. Then we use the AES encryption algorithm and ESP SHA-256 HMAP. Okay, no problem. Done. After that, but now here what we are not going to use, access list we are not going to use because this is a route based VPN, right? And let me copy this much first because after this we will have a change. Phase 1, phase 2 configuration is same. Yeah, here is correct. We will change it. But first of all, I'm showing you configuration on site 1. Some spelling mistake. Crypto. Where? Crypto also correct.
We have to add IP.
No. Actually, we have to exit from here. Okay. Yeah, after lifetime. Address keyword here. Forgot the address keyword here. Now it's fine. Okay. This is clear. Now see here. After this, what we are not going to do, we are not going to create access list. And after access list, what we are doing? Crypto map. So we are not going to use here crypto map also. Okay. So instead of that, what we will say? Crypto IPSec profile. And here we have to give a name to this profile. Okay. So let's name it something like IPSec profile. Same name. We are creating this thing. Now in this profile, what we will set? We will set the values for encryption, decryption. Like in the crypto map, what we were doing? We were setting the transform set, right? That transform set you set here. Set. We get an option for transform set. So I'll say transform set. What is the name of my transform set? Tset. This is done. Exit from here. Okay. Now this IPSec profile where we will apply the tunnel interface. So I'll say interface tunnel 1. And here we will say here you will use the command tunnel protection IPSec profile. And what is the profile of IPSec? IPSec profile. Done. You see IPSec is on. Okay. Now it is saying that received a packet which is not IPSec because on the site 2 we haven't configured it yet. Okay, and because of this, you see your EIGRP neighborship is down, and also your tunnel interface is down. This is clear. So what we did here, after this, we created a IPSec profile. And after the IPSec profile, inside the IPSec profile, we applied transform set. We applied the transform set. Okay. And then we went to the interface, tunnel 1, and here we applied the IPSec protection to the tunnel. Okay. This is your GRE over IPSec. Now same thing we will configure for site 2. Copy. Paste. In the site 2, what will change? Peer address. This is only going to change, which will be 11.1.1.1. Let's copy. Site 2. Paste. Tunnel interface change state to up. EIGRP neighborship came up. Now your traffic is secured with the IPSec. Okay. And see here, packet capture is going on. Do you see automatically negotiation of the tunnel? Why? Why the tunnel was automatically negotiated? Exactly. That means EIGRP was sending hello message. So automatically packet was trying to go from source to destination. And this is a route-based VPN. We don't have to match any access list here. Only the traffic has to pass through the tunnel interface and automatically tunnel will be negotiated. Right? So that's why we have here this thing. ISACAM, 6 messages mean more, 3 messages. And after that, you will not see anything. Not even EIGRP messages also. Why? Because they are also passing through the tunnel. And the tunnel is secured with the IPSec. Okay. And now let me test communication. First of all, do show IP route. I can see I have a route. And I can say blueprint 10.2.2.2. I don't have to give the source this time. Source we needed in the policy-based VPN only because we were defining ACL. Here, even if I don't give it, this traffic is also going through the tunnel only. Okay, and nobody will be able to see this traffic also. This is clear. Now, here if we see right now any of these packets, we are just having one header here. Correct? We are just having one header here, and after that everything is encapsulated. But imagine actually what is happening. Actually, what is happening? That first of all, I have ICMP message, which will have IP header. Then that IP header will be encapsulated with a GRE header, right? Let me draw it. See here. First of all, we have ICMP. Your ICMP we have. Above the ICMP, we will have an IP header. Here we have IP header, which will have the information that the traffic is going from 10.1.1 or 192.168 to 2.2.2. Okay, so this is IP header. Then this thing we are encapsulating with the help of GRE. First of all, GRE, right? So here there will be GRE header. Right? And this GRE is providing a GRE is providing what? New IP header. So we can call it like GRE IP header. Okay. Now by default, see IPSec two modes, tunnel mode and transport mode. And by default, the mode is tunnel mode. In the tunnel mode, your entire original packet is encapsulated. That means this is entire payload. This will be encapsulated. So we will be using either ESP or AH. Right now, what we are using? ESP. So here we will have what? ESP header as of now. Or if we are using AH, in that case, AH header. And then there will be one more IP header. So that means in one packet, how many IP headers? Not 6. IP headers. 3 IP headers. Where this will be the actual, let's say, for example, the traffic is going from 10.1.1.1 to 10.2.2.2. That when GRE will do, GRE will use public IP addresses to 12.1.1. And here, this is also using public only. So 1, 2. Right? Now IPv4 header, what is the size? What is the size of IPv4 header? What is the size of IPv4 header? I'm not asking IP address header, IP addresses. Size of IPv4 header. Google it, no problem. What is the size of IPv4 header? That is TCP header. Size of IPv4 header. And default size will be 20. TCP 20 to 60, but IPv4 header size is 20 bytes. So that means here, if I see my IPSec is encapsulating the entire packet, right? If I see here, my IPSec is doing what? Encapsulating the entire packet. That means this much part. This is being encapsulated by ESP. So that means actual communication is, the public communication is happening using this header. And when when my loopbacks are trying to communicate, they are using. So what is the use of this GRE IP header? Actually, no use. So we will remove it. We will remove it. How we can remove it? See here. Now this is happening because my IPSec mode is what right now? Default mode I'm using, which is tunnel mode, where entire packet is getting encapsulated. Correct? Okay. Okay. This is tunnel mode. When I will go with the transport mode, in that case, what will happen? The transport mode. So here, entire packet is encapsulated. Okay. And in this case, only payload is encapsulated. That means IP header will not be considered as a payload. Okay. So in this case, what will happen? You will have ICMP. You are going to have here ICMP. Above the ICMP, you will have a IP header. Correct? Here you will have what? IP header, and this will be from 10.1.1 to 10.1.1. So 10.2.2. Right? Then this will be encapsulated with the GRE. GRE will put GRE header. Here, GRE will use what? GRE header. And above the GRE header, no, it will use what? IP header. So let me say GRE IP header. Okay. So in the tunnel mode, we saw that what was happening? This entire thing was getting encapsulated, right? But now since we will use what? Transport mode, only the payload, this IP header will not be considered. Only this payload, this is considered as a payload. No, that is the original payload. To IPSec, what is coming as a payload? This GRE with the GRE header, IP header. So this IP header will not be considered as a payload, but anything inside the GRE will be considered the payload. So only this much thing will be encapsulated. So once you change the mode to transport mode, what will happen? This will be removed. Okay. This IP header will be removed. Okay. And instead of this, your ESP encapsulation will be used. So whether it is ESP or AH, whatever you're using. So this will be the ESP header or AH header. And then above this, your IP address header will be used. Reduce 20 bytes because one extra IP header we don't have now. This is clear. But again, if I have an IP header, I have ESPH, I don't need the GRE header also. So when I change to transport mode, how many bytes I saved? 20 bytes. I saved how much? 20 bytes. Now, like I said, we have one concept, that is what? SVTI, Static Virtual Tunnel Interface. So with the help of SVTI, what we can do, we can remove this GRE header also. And what is the size of GRE header? No problem, Google it. You'll get to know. GRE header. 4 bytes. Yes. Size of GRE header is 4 bytes. So that means when we will use SVTI, even this GRE header will be removed. If this GRE header will be removed, total how much space we will save? 24 bytes. The total amount of space we are going to save is what? 24 bytes. Exactly. Okay. So that means these small points you should note down that GRE header size is 4 bytes. Okay. IPv4 header size is 20 bytes. So see here, this is transport mode. Now I'll copy the same thing. Here we will inject one extra pin, that is with SVT. So this SVTI will do what? Will remove the GRE header also. And what we will get? This. Okay. Here we save 20 bytes. Okay. So here we will save what? 20 bytes plus 4 bytes. Total 24 bytes. 20 bytes for IP, IPv4, and 4 bytes for GR. This is clear. Now, how do we practically see this thing? So in ESP, it is not possible to see the content inside. So we can see using AH, right? So we will implement AH, and with the help of AH, these all practicals we can perform. Clear? So let's go for it. So to implement AH, I don't really need to change a lot. All I need is here I have to say AH SHA Atma. This transform set I will change. Already the transform set is used here. No need to change anything else. And this command will remain same on both the sides. Copy. AH does not provide encryption. Yeah. So AES, SHA, these will come under ESP and AH only, right? Yeah. So paste here and also here. No, we are not using AH. Always ESP will be used. Now, this is done. Capture is already going on, I guess. Monitoring, testing, we can use. So right now ESP, okay. I'll say clear crypto session because my tunnel is already established, right? And I have to use do here. Done. Again, my automatically EHRP neighborship will come up. Tunnel came up. Do you see? Now I can see the EHRP messages also. Earlier I was not able to see. Okay. So after this, we can see the EHRP messages and you can see how many IP headers are there. Right now we have 3 IP headers. One is for tunnel, another one is for that is the GRE, and this is for the what IP header the IPSec has used. Okay. So now what? These are 3 different headers. First of all, what we will do, we will change the mode to transport, and we will see this IP, this header will be gone. This extra header will be gone. So we will see AH and directly we will see the GRE. Okay. All right. So right now this thing we can see, or else if I try to ping also, you can see. Now, how do we change the mode to transport? So see, we created this transform set, right? With this transform set, here you can mention mode transport. Okay. So what I can do here, I can say chargement. Yes.
We have already created with ESP,
Mhm.
AES, right? Without removing in construction, we add this AES.
Yeah. So automatically see earlier also transform set name was T set only. So same transform set now I'm applying AH. So this is overwriting the previous configuration.
That will automatically.
Yeah, that will automatically remove. So here I said what? Mode transport. And here also now I'm going to say the same thing. Mode is what? Transport. Okay. Once I set the mode to transport, now see here what will happen. See, As of now, the tunnel is already established, will not change. So what we have to do here, vector session. Now you can see I have authentication header. Directly I have GRE header. I don't have the extra IP header. Right? So 20 bytes we have saved. 20 bytes saved already. Now I need to remove this GRE also. I need to remove this GRE header also. So to remove this GRE header, what I have to apply? SVTI. I have to apply SVTI. So how do you apply SVTI? Just one simple command is there. Not a very big deal. Go to the tunnel interface. Interface, tunnel 1. And here you will see tunnel mode IPSec and IPv4. This is the command. Tunnel mode IPsec, IPv4. And same thing you go and apply here. Interface, tunnel 1, tunnel mode IPsec, IPv4. Now, once you do this, tunnel should come up, your AGRP neighborship should come up. And if this comes up, everything is good. And since tunnel came up again, now see here. Do you see GRE header anywhere? No, right? Directly we have AH and then we have the IP header. This way we can save 24 bytes.
Can you explain why we use mode transfer?
Which one?
Mode transfer.
This one. Because earlier what was happening, see here. See here. Earlier I was having 3 different IP headers. Right? Earlier I was having 3 headers. One for the ICMP or whatever AGRP, whatever the payload is there, that will use one header. Then this was encapsulated with the GRE. So GRE was using one header. And because the tunnel mode was there, so in the tunnel mode, what happens? It encapsulates the entire packet. Okay. According to tunnel mode, this will encapsulate everything. IPsec encapsulated everything. No. See, always remember MTU is fixed. So if you increase headers, header sizes are more, automatically your data size will be what? Small. Okay. So we don't want more headers. No. Security doesn't have anything to do with the headers. Here is your IPsec who is providing you CIA. Right? So IPsec was always there, right? See here. Security was always there. Doesn't matter you are using 1 header, 2 header, 5 headers. Okay. So in the tunnel mode, what was happening? That everything was getting encapsulated. Okay. So like this was, it was considering this as a payload and it was encapsulating everything. Which one? We will use because we don't want in the real scenario. This is only what you're going to use. You are not going to transmit a lot of headers. Yeah, definitely. We will not use AS. We will use ESP here. Just to see. Otherwise, we won't be able to see that headers are getting removed or not. I'll apply back ESP again. Okay. Actually, what would happen that if I showed you the same thing over ESP, you would never understand what happened. Right now, at least you saw. Theoretically, I have explained here, but practically you would not be able to see. Right. So for practical implementation, we used EH. And this is one of the reasons you use EH. Okay. For understanding. So this is clear. Online people. So earlier we were having 3 headers, then we changed the mode to transport. That one IP header was removed. Okay. Then after this GRE header was extra, so we enabled SVTI, and after that we removed the GRE. So total 24 bytes we saved. Okay. And your communication, now this is what? Right now you'll say we are able to see the traffic. So we'll go and change it back to what? ESP. And once we change to ESP, then everything is good again. So let's go and change it back to ESP. ESP. AES. ESP. SHA. Okay. Let's go with 6. See, this and this, they don't have to be same. Okay, it's not mandatory that these two have to be same. Copy. No, you can use different. These things are local only. You can use different. In the system. Panel protection like this. Definitely, MPU switch, right? So here we set panel mode, IPSec, IPSec mode. This one comment here also. Here, mode as transport. So now that's it. Here, crypto session. Do we? Once this is done, panel came up. AGRP came up. And in the capture, now we will not see anything. It's all ESP. Okay. So now, this is what in our real scenarios you will use. Okay. Now we can test also. Do pin 10.2.2.2. This is the, actually good thing with the AS actually, you don't require do command. Like here you say show IP interface brief, there show interface IP brief. Right? So like that. So this is clear. This was your GRE over IPSec with SVTI. Okay. Online people, any doubt in this part? Hmm? Payload, data. Your data is payload. Okay, anything coming to a layer, previous part is what? Payload only. Okay. That means you remove the headers, the rest is whatever you have, that's it. This is clear. Now, for you to research about NHRP, NHS. Okay. Then with this MGRE and DMVPN. Okay. So we'll go with DMVPN, then IPSec over DMVPN. Okay. Then after we will see dual hub configuration of DMVPN. So DMVPN will take us around 2 to 3 days. Yes. MGRE will take one session. So Monday MGRE, next 2-3 sessions DMVPN. Then finally we will move to IPVT. No, before that we will have VRF Lite available. Combining everything about. So everything we are doing in one lab only. See here. Every time our topology is this only. How? If you want two sites to communicate, they should be running the same thing, right? The thing is, if you want, let me change the name here. This is actually what he's trying to say is there should be one lab in which he can configure everything. So multi-site GRE will be there, right? Next is what? MGRE, multi-site GRE. That will be static. Then that part we will automate. That will become DMVPN. Okay. But if you think you want policy-based and route-based at the same time, not a good idea. Okay. Clear? Online people. Okay, so these things you have to check for the weekend. Monday.
Configure one side is configure tunnel mode. Another side is configure transport mode. Is it possible to configure?
Didn't you see that tunnel immediately went down when I changed mode on one side? Okay, that will not be possible. Okay, so this is our next session, Monday. How like the tunnel will be the same. Tunnel will be created. Only encapsulation changes are there. Okay, that here it is encapsulating the entire packet, and the transport mode will encapsulate only your payload. One person working in two different companies. That is your what is it? No. First of all, tell me whether it's the same company situated in different countries or different companies. No, not possible, right? One company, let's say, if I'm having a company, so I will have communication with my sites only. I don't want a private communication with anybody else. This is the overall reason, right? Why we are creating VPN. Because from my site, my headquarter to my branches, I want secure communication, and nobody else's traffic should be there. That was the overall idea. But if you want somebody else coming in between, that is not possible. Okay.
Multiple one device connected to possible.
One device. You mean to say PC? No. We do have a split tunnel concept where, like, if you want to go to the internet, your traffic will directly go to the ISP. And if you want to visit your branch, that is going through the VPN tunnel. That is the split tunnel concept that we have. So in that case, you can say, because when you're going over internet also, you're using SSL clientless VPN. And when you will access the company, that will be full client, or you will use a client-based VPN. That is possible. So yesterday I explained, right? That is possible. Like from remotely you can connect to site, and from site you can have other access. That is possible. Okay. These confusions, they will become clear once we study the remote access VPN. Okay, so as of now, you search about these points, and Monday we'll go with MGRE, then after DMVPN. Clear? All right then. I'll see you guys on Monday.
So then question, out of question, but when we compare, so teaching together, which protocol is from plus
Which protocol?
from plus?
Like what we are trying to say here. That will again depend on your TCP/IP implementation. Like normally what you will see is this loopback protocol. That PCs, they will try, once they will come in network. Now, if it is Windows PC, the IP address will be set to by default. They will start DHCP also to try to get the IP address. Okay, then GR when you have the IP address. GR will be there when you have already have the IP address to announce or to check the duplication. Okay, so these kind of loopback packets will be there. Okay, these kind of loopback packets will be there, and if DHCP is implemented, DHCP will try to get the IP address. Okay, so many protocols can come in picture, because let's say, for example, there your bootp protocol can also come in picture when your PC is trying to start up. Okay, so that time also your PC can try to get an IP address during the booting time. So when booting time, when it is taking a IP address, bootp will be there. And when you have your system is already started, after that you're connecting, it will use DHCP. So that will depend completely on how your TCP/IP implementation is there in the device. You cannot say one fixed protocol. Okay. Topics. Still so many left. Don't know. We just have studied, I think, 10 to 11 different scenarios. So let me show you what are the topics. We are just here. This is only what we have completed. Now MGRE, then DMVPN, like I said, 2-3 days it will take IPSec over DMVPN dual hub. Then we have overlapping. NAT-T we have already seen. This is done. Okay. Then after GAT VPN, we will see VRF Lite, Aware VPN, we will see. Then finally we'll come to one day IKE will take. And then IKE implementation, Flex VPN, resolution. Now you can see. Okay. So Flex VPN will be there. Then we have SSL VPN and CA-based VPN, L2T. So out of 16 right now we are at. Which one? Where? Or remote access VPN. These are all remote access VPN only. Okay, your SSL VPN is what? Remote access VPN only. So those will come here. You have to wait until then. Okay. Still, we have so many topics. We are just starting number 4. Okay. How many labs? Every single day there will be a lab. Okay. So whatever the number of sessions we have, that many labs will be there. So see, today we will have 15 more labs you can consider. There will be no firewall. Okay. This is clear. So this is our Monday topic. So next week, this thing we will complete. Route-based VPN mapping is not supported. This was a task for you, policy-based and route-based difference. Okay. So this is what we'll complete next week. NAT-T we have already completed, so you can consider next week we'll complete this one. Then another 1 week for this part, 2 weeks, and then 1 week. We might have to take extra sessions. But we'll go with 1 VPN every day so that it will be easier to understand and you guys can also practice. If needed extra time, we can take it. No problem. Monday CH I will start. Interview prep. Then 23rd of September I will start with ESA and NGIPS. Your NP should be completed at least. Okay. Study advance. Okay.